Hello, everyone. Welcome to our next session. This is our last tech session of the two-day Dev Summit. It's been such a pleasure to end it with Pradeep Sharma. And he's going to be talking, the subject of his talk is building private LLM-powered second brain on Intel CPU. A little bit about Pradeep. He is a computer science researcher, software engineer, tech founder, and author with a decade of experience in developing applications across developer productivity, privacy, neural search, and authentication. He has worked at L3S Research Center in Germany, contributed to startups, and founded 2 tech companies. Pradeep is also the creator of Developer Diary, a cross-platform productivity tool for developers, and the author of both a developer-focused book and #open source discovery newsletter. His experience in engineering and open source communities gives him a unique insights into how technology evolves. And with that, I wanted to welcome Pradeep to the stage. Over to you, Pradeep.
Thank you, Sri. Glad to be here, and thanks for inviting me here. Let me share my screen. So, hey everyone, I'm Pradeep, and I just shared my screen. Today, okay, so I hope it is visible to everyone. So today we are going to talk about private LLM-powered second brain that can work on Intel CPU and most of the consumer-grade hardware that many people have. That's the kind of hardware that we are talking about, where you can use LLM to create a second brain app. So how I did that, that's what I'm going to cover here. So right now you will see a couple of questions on your screen. If you can answer those, it will help me to decide how to move forward with this talk. Okay, so this is the overall agenda. We are going to cover first about me, what experiences led me here in this talk, and the curious case of unfinished projects, the problem and the solution, the development journey I had in building this private LLM-powered second brain, and what worked, and eventually the conclusion. So starting with about me. So I studied electronics and communication engineering at IIT Roorkee, and after that I have worked in software engineering as a developer, as a tech founder, and currently I'm consulting companies for developer relations. So in software engineering, I have more skills towards the back-end side and less on the front-end side. Total 12 plus years of experience, and I run this newsletter called Open Source Discovery, where I review developer experience of some of the open source projects, what's good and what's bad in their developer experience. I also founded Invite, which is a community of remote developers who come from remote areas, like non-urban areas, villages, small towns, tier 2 cities. And I've been brought up in a village, and currently I'm living in a small town near to that village only. And there are specific aspects of people who come from such areas, especially their aspirations and challenges that I could connect with, and that's what led me to build this community in Invite. And that's the most of the India, more than 75% people come from non-urban areas. And specific thing about these people or this audience is that they are not that connected with the technological opportunities. For example, if you talk about work opportunities, you wouldn't find them in tier 2 cities or villages. If you talk about networking events, these big conferences, they will happen in big cities only. Financial resources, they are also more established in the bigger cities, but not in the non-urban areas. And as I said, that's the most of the India as well, most of the world as well. But in India, it's even at the peak because more than 75% of India lives in non-urban areas. So I wanted to build a community for them and solve their specific challenges. And while working on that, I built this developer diary, which is a privacy-focused developer productivity tool. And because of my interest in this hardware, software, and doing something for people who come from remote areas, specifically developers who come from remote areas, that's what led me to build this tool that we are going to talk about. So you will see some of these questions on your screen, and in the poll section, if you could answer those questions, it will help me to prioritize what to focus on in this talk and what slides should I skip. Okay, so moving on. Unfinished projects. Do you have any unfinished projects? I have many of them, and the developers I meet, they have lots of them, lots of unfinished projects. We start building something, then we get busy with something else, and then that project remains unfinished. And that's, I guess, a lot of people agree with, because of, you can see that those conversations on online, as well as the people that you talk to, you realize that it's a common thing to have many unfinished projects. And we wonder that how can we finish more of our projects? And one particular thing that, as this Reddit user points out, that having these many unfinished projects dissuades you from starting new projects. So how can we deal with that issue as well? So that's one thing. And another serious thing is the anxiety, work anxiety. Many people on social media, in personal life, have vocalized that they cannot sleep because of the work stress. And these are just some of the examples that I found online in communities. And specifically in programming, a lot of people have been complaining about the stress, even the anxiety attacks. So what's the solution? So one solution that has worked for me, and many have also communicated the same is, if you are feeling anxious today, write it down, journal it. Whatever you're thinking, just put it down on the paper. And if you're worried about tomorrow, then just you can just delegate the unfinished work to your AI second brain. And that's the solution that we are proposing here. A lot of people, when it clocks out as 5 p.m., they get stressed because their work has not finished, or they are not satisfied with their work. And it's much common in developers. And usually that leads to longer working hours than they were supposed to, or even they promise themselves that they will leave office or work at 5 p.m., but they don't. So the problem, the thought behind that is this anxiety of not doing enough, or anxiety that you can do more, that doesn't let you leave work at 5 p.m. And in remote work environment, it's even worse, because work and life boundaries have been removed, and people end up working all the time. So the solution to this, I started, so this was a hobby project that I started in a long time back, but seriously around 2020. And this is a desktop app which is available on Linux, Mac OS, and Windows. What it does, it's an app for developers, and when the time is when you set a time for yourself, let's say 5 p.m. or 8 p.m., whatever time, that you want to leave work and focus on your life, that's when the work of this app starts. You write down your thoughts, whatever you want to write down, in whatever way you want to write down. just simple markdown, single file, no complex stuff. And usually how I use it, I write down what I did in the day, any unanswered questions that I faced during the day, anything that was not finished and I would want to look into tomorrow. So those are the thoughts that I have in my mind at the end of the day, and that's what I write down here. So that's the first part. And but back then there were no LLMs, and we couldn't do things that we could do now. And that's the second part, which brings me to this upgrade that we are going to talk about, and that turns this app into a AI-powered second brain. So this is just an example, a real example of what I was doing in Jan 8, 2021. So this is how you write down. This is just an example. And so it's 5 p.m. I write down that this is what I have done. And this is the upgrade that we are going to have now in this app. And it's going to prompt you, do you want to delegate your unfinished work to AI? And you can let your worries about not finishing something or moving slow on some project. You can leave those worries to this AI powered app. So you can choose whether you would want to trust this AI to take autonomous actions, or you just want suggestions from them and review it and then only act. Mostly, I will choose going one step forward in my task, and then it will ask you to give you some permissions that what autonomous action do you want to allow it to take. For example, if I'm too cautious, I will just simply choose deep research, that do some deep research in particular area, whatever was remained unfinished today. Or there are other examples as well. For example, you can let it code and raise a PR. You can let it ask questions in forums. You can let it contact people and all, and many more things that might come up or the community can build. So what will happen after that? If you do so, this is what happens. 3 steps. First, this app organizes your thoughts and the data that it collects. So it collects 2 data points. One is the node that you just created in the journal. So that creates a high level context for what this user is doing or what this user is thinking. That's a manual entry of data that's coming from the human. And second is automated data collection. And in that, what do we collect? Computer activities. And in computer activities, we collect only the app name that you are using and the title that you are using, and we create a timeline of that. So if you think of what we are doing here, we are letting this app go through the same experience that you had gone through today. The same flow of activities on computer. It has context of the thoughts that you put in journal, those thoughts as well. So in those thoughts, usually you end up sharing your experience, which couldn't have been captured via simply this automated data collection. So the first thing it does, once you clock out at 5 p.m. and you come back at 7 a.m. Tomorrow, between that period, it does, these are the 3 things it does. One, organize. So it organizes that data that we collected. It adds certain tags, or sort of, you can say that label the data that we have. And we use a simple model, word to vec here, with with this chain of continuous bag of words. And then second thing it does is to reflect. So now that we have data organized, we reflect on it. The nodes and the labeled customer activities, these are the inputs to this LLM. So it's a sort of a chat with LLM action that we are taking here. And we have some prompts which helps us, which prompt the LLM to reflect on this data that we are giving to the LLM. Usually, in the end, I ended up using DeepSeek R1 7 billion, which has been distilled from the Quen 2.5. This is a mistake, not Quen 2, Quen 2.5, and a Q4 quantized model. So that's what I ended up. But I also used other models as well, which we will cover later. And eventually, the third step is to act. This is again another chat with LLM, but sort of the next level of the chat, where we also include tools and agents, and in future support for MCP as well. MCP is multi model context protocol. So this is a protocol which helps standardize the context that we give to LLMs. You can create your own multi MCP server, which will enable certain actions. For example, the LLM can just invoke your server, let's say read file, and then whatever you give it, it will have that. So what will happen when you come back at 7 a.m. tomorrow? Then you will see that it has analyzed, this app has analyzed, and it will show you that what unfinished work remained from yesterday. So you will be able to see that, and you will also be able to see what AI did about that. For example, when I just showcased you what I did. So these were the notes that I had. And in the background, there was a data about the computer activities as well, which was sort of how I approached my work during the day. And it will also have some things which, for example, research, which were unfinished, or any work that was unfinished. And from this, it understood that I had this issue, because it was shown in the data, this computer activities, that I was researching about Electron MES app deployment, and it went on for quite some time searching for a solution to a particular issue, but eventually it did not get done. So it understood that this was an unfinished thing from the day. So what will be the next action that it could take? So next action was that it posted the issue that I had in Electron, the program which had a problem, posted a question in that community. And also it did some research around what new things that I could try, including the code and summarizing a particular step, so that when I come back here, I get inspired that, yes, I should try that. So for example, it says that check that Apple's developer certificate is correctly set up or not. So that's a very good cue for me when I left my work to, again, then I'm coming back to my work. It's a good cue for me to pick up from, and I get productive immediately. So this is overall how it works. But AI the second brain is also used very popularly by other apps as well. For example, Notion, Evernote, Obsidian, and Developer Diary we are talking about right now. So it works sort of an extension of your mind. When you were going to sleep, you let the second brain work for you. And it reduces your cognitive load, improves productivity, and improves learning and creativity. You can think anything like what it can do. For example, it can create a personalized learning plan for you. So yesterday it saw that you were struggling with particular concept, and it can create a bite-sized learning plan for you, that right away when you come back, you just spend a couple of minutes, 10 minutes, 15 minutes, and then having that knowledge will make you more productive. So this is another thing. autonomously working and completing a task. That was the thing that we discussed. But I'm specifically mentioning this learning because it looks tiny but has a huge impact on the productivity. So these are the three things that we are talking about in the system that we are building. One, it is works as a second brain. Second, it is powered by AI. And third, specific thing that you might not have noticed yet is that it works offline. It does not send any private data to any LLM on cloud. So you do not need to trust any third-party LLM. You do not need to trust your network that is delivering your data to that LLM. And this brings you more security and peace of mind because we are dealing with a very sensitive data, your personal thoughts in journal and your computer activities, what you are doing on the computer. So those things remain in your computer and LLM in your computer or in your local network. So I guess why do we use AI for second brain? This is something I would say that, and you could guess, or I wouldn't spend more time because we have more things to cover. And I see that 50% people have never tried local LLMs. So that gives us, we need to spend more time on that part. So why offline, as we said, that privacy, security, and cost. Of course, you do not spend money for these calls because it is going to take a lot of LLM calls to do this stuff that we are talking about. And accessibility, when your internet is down, you can still access it. So for developers who come from remote areas where network accessibility is a concern, they can have a peace of mind that even when the internet is down, even for a moment, this app will work. They won't get blocked when they are, let's say, journaling, although it works offline. So it does not need any sort of internet connectivity, neither for writing down nor for any AI-related actions. So this is why offline is very important, critical for this app. Now I will walk you through my development journey, and that will leave us with some of the takeaways, what we can do when we want to self-host LLM locally, and also anything that we want to build which is private, offline, and accessible. So number one thing, as I said, that because we are building this for people, for the majority, people who come from areas where you do not have the luxury of neither the network connectivity nor the computation that is available to you. So I run this community called Invite, and I ran a survey there, and I learned that most of the people, around 70% people, use this configuration, Intel i5 or i7, and between 8 to 16 gigabyte of RAM. So this is the configuration that I wanted to build this app for, that it should work without this person noticing any glitches, any performance issues. So for that, I started with very simple thing. I thought that because this is going to take a lot of huge bandwidth, not only in terms of RAM, but CPU, it will consume almost all of your CPU. When we are talking about this everyday computer, then it will consume almost all of your CPU. So, and if you are coding, you are working on your software engineering work, then you wouldn't be able to do anything at all. So it won't make sense for this app to run LLM all the time at the time when you are coding. So the first solution before I changed things a bit was to use a simple Raspberry Pi. So I have this Raspberry Pi, this makeshift model. This is Raspberry Pi 4, 8 GB RAM, and as you know that sort of a processor which is not that suitable for such tasks where you are running an inference engine. But still, I tried that, and the best thing that but the best way that I figured out to run LLM on Pi 4 was to use Llama file. Llama file is a project which packages all your LLMs, weights, activation, and everything in one CPP C++ code. You simply run that C++ code, and you are good to go. It does everything else, all the optimization that you need for you, and you're good to go. So that was the easiest start for me, and I started there. And what I learned was that it's not for a serious thing. It's good for just playing around like toys. Sort of, you created a toy. The tokens that the token per second performance I got was very disappointing. It was even hard to get 1 token per second for me to on this Pi 4 that is running Ubuntu 24 and 8 GB RAM on the latest model. So that was out of the question. So this was a failure. And then I did some more research that how can I. So there was no other option left that I need to come back to the machine that this person is working on. But before that, I thought, let's try another thing. And the second thing was that usually we have a second-hand machine because we started using computers long back. We have an older machine, and as these specs upgraded, we started using another new machine. For example, we were using i5, and then i7 came, and then we started using that. Or if in coming years we will start Intel Ultra Core, and then our laptops or computers that we are using right now, they won't be used as much as we would want them to use. So why not use those computers, those machines to run an LLM on a local network, so that this app is running on my system, but any inferencing that I need to do, any chat that I need to do with LLM, it will route that to my machine that is on my local network running an inference engine. So there were 2 things that one can do to overcome the limitations of the hardware. One is this model compression. So you reduce the size and computational requirement of the model. And second is you optimize the inference engine itself. So earlier when we used Llama file, this was done for us. And when we use this quantization, this model compression was also done for us. And usually these days, you will be good to go with these.
Hey, Pradeep.
Yeah. Go ahead.
You turned up screen share. Were you supposed to be screen sharing?
Yes.
Okay. Just want to let you know that the screen share turned off.
Okay, I'm starting the screen share again. Okay, just a moment, and we are live back. Okay, I hope my screen is visible now. So these are the 2 things that you can do to optimize the performance of your LLM inference, model compression, and inference engine optimization. And I guess we had a talk by Mariam in this AI DevSummit, and that is a good primer for this. She covers most of these points, these best practices for you to optimize your LLM inference. So just to quickly give you overview, one is if you are not aware already, I'll just take 1 minute. So quantization is that you reduce the precision of model weights. So usually they are trained in FP32, and you reduce that weight to in 16, 8, or in 4, or something like that. And another thing is pruning where you remove weights, unnecessary weights that do not add that much value, or the complete neurons or layers itself. And the final thing that is distillation, which DeepSeek is very famous for, how they distill. So distillation is basically using a teacher model, a bigger model, which does a great job to teach the behavior to this smaller model. So that's what DeepSeek had done very well. So this is the model computation, and then inference. What kind of things you can do in inference engine? You can first leverage all the cores that you have available, add some CPU specific optimizations. For example, OpenVINO does that, and there are other libraries as well, which will help you optimize your LLM inference for a specific CPU, and leverage some of the specific ISA specific features which are available in modern CPUs, for example, AVX 512. And also, one example is Llama CPP, which optimizes metrics using matrix multiplication kernels. So this is another thing. And one particular thing that I would like to emphasize here is prefix caching. All these things have been any inference engine you use these days, popular inference engine, whether Olama, Llama CPP, or any other inference engine that you use. They will give you all these things. Prefix caching, this is sort of new. I would say that it's might not be available in all the inference engines. And even if it is, you can still think more about that. What is prefix caching? When you chat with LLM, you give it a prompt, and then it works on that, and then you give it more. You basically continue the conversation. So usually, if you create a chat point at a point which is needed for almost all your requests. For example, in our case, we give a prompt to our inference engine, and that's what we need for every request that we do. So if we can cache until that stage, then it will be much faster for us to continue the conversation, and we will see that tokens per second performance will improve by a huge margin. So this is something which you should dive in more. Now, before coming to even more practical things that you should think about when you are running an LLM on a local system with consumer grade hardware. First is be practical. That's first thing. Actually, if I can go back, I will tell myself that be practical, because when I started, I was very ambitious to try higher models like as we talked about, 8 to 16 GB was RAM that we had available, and CPU was i5, what we targeted. But I was trying for 13 billion parameter model, and trying for FP16 quantization. Basically, that's not possible. And even if you go with the quantization, let's say 7 billion is sort of that falls into a practical limit of what you can do on this consumer grade hardware. So 7 billion parameter LLM model with quantization. And I will, although you should try that, but if you ask me, then I will choose int 8 or int 4. Int 4 I wouldn't go, but I will try for int 8 if possible. Otherwise, I'll go for int 4 if the performance is not satisfactory. So this is something that we need to be very judicious about, that we should be practical about our expectations, what we can do on CPU only machine. with a consumer grade hardware. So now that you are practical, so actually let me tell you more that how in context of our second brain app we became practical was that one, we cannot run this model, this 7 billion model on the computer, and while this developer is also doing their everyday chores on that computer. So that's not possible. So that is one thing that we became very sure of. That's what we need to do. And second is that we chose this 7 billion and quantized model, and we chose to do these computations, do this process at the time when the computer is not in any use. So either do it during that window when this computer is not being used for anything else, or do it on a completely different system that is available on your local network. So these were the things, practical decisions that we took, and it also means that you change the requirement you have itself. So and also you bring down your expectation about the performance that you were expecting earlier. And also you start using tiny models for tiny tasks and not the LLM tasks. If you need something in the moment, use that tiny model. So for example, we used tagging, we were using a different model, which was not an LLM. So this is one key learning that I had. Second thing, this was going in my mind that how would we make it distributed and all? Why not use multiple CPUs on different? But that's not possible, and that is because of the design how LLM or this neural network works. And the tokens computation relies on previously generated tokens. So this is one of the important thing to remember when we think about optimization and not promise ourselves too much or go in the direction of waste time. So that's something for that. And prefix caching, as we talked about, do think about that. Most of the many inference engine will give you out of the box, and I ended up using Olama in the end, but in Llama was CDP as well. I think you have this. You can do this prefix caching, and VLLM for sure has prefix caching. So depending upon your choice, I would say that if you ask me that what I would choose, then if I had more time and more control, then I will use Llama CDP and make sure that it does prefix caching. And if not, then I will go with Llama itself with little bit downgrade on the performance, but speed and agility in development. Okay, some of the important things that these are sort of hacker kind of things or a gamer kind of thing that you would do is that you prioritize that process, whatever this process which is running this inference, you prioritize that process. You can use these commands, nice and chrt, to do that. And second thing that you can do is that you force load the model into RAM. If possible, if you're using a smaller model, then just simply load it in the RAM. And in Llama CP, you can use these arguments to do that. And very simple, again, around the being practical, truncate unnecessary data. It almost, so we reduced our token size that we were feeding to LLM by 50% when we paid attention to that. Otherwise, it would have been really hard for us to deliver those results. So yeah, that's about the overall my journey of development of this second brain AI powered app. And if you like this, do check out my newsletter, Open Source Discovery free newsletter, where I cover review of new open source projects, and I try to distill what's good developer experience, and what's bad developer experience. I've been running it for quite some time, 5 to 6 years it has been. And you can connect me on any of the channels. Yeah, that's about it. So thank you everyone for listening, and thank you for inviting me here. Any questions, I will be happy to answer.
Okay. Let me see. Thanks again for your talk, Pradeep. I have one question. Is prefix caching the same or similar to memory?
Great. No, you can say basically you can use memory as a part of another optimization, because you are running a lot of LLM requests which are kind of duplicate. Uh, but prefix caching is more about checkpointing at the LLM level, where it has so as I said that the next token generation depends on the previous token generation. So if you already have those tokens there at the checkpoint, then you can move forward to the next token faster. So that's at that level. But this is also very interesting point, because that's exactly what I did in my because that particular concept actually inspired that. Because we were doing these conversations. So if I have reached a certain point of that conversation, and again I have to reinitiate or feed the next user prompt to it, instead of giving the complete chain, why not give us a summarized version of that a particular chain? If you are not using the prefix chain, why not give a summarized version of that, so that it reduces your token requirement, and also keep your LLM inference focused on the task that you have.
All right. Checking to see if there's any more questions. I do not see any more, Pradeep. I think we're probably done with our Q&A in this case. Does anyone have any more questions? I can wait another 10, 15 minutes. I'll check the chat. Okay, I think, thank you, Pradeep, for your talk, and appreciate you coming on stage and sharing your expertise with us. And we hope you'll come back. For our audience, we will do the last session, the goodbye session, in 8 minutes, and so, or now 7 minutes. So please hold on till then, and we will close this DevSummit out. It's been a really great day sharing with all of you. So we'll see you there. All right. Thank you, Pradeep. Have a good one.
Thank you for inviting me.
Yes, absolutely.
Awesome. See you. Bye-bye.